Hello, today we are moving on to Unit 8, which is our quadratics unit. Quadratics are any equation that the highest exponent, which is the degree of the expression, is x squared. We want to have a squared. It doesn't have to be x, it could be whatever letter we're talking about, but the highest exponent has to be a 2. So right here in the do now, we're asked to graph this function y equals x squared. X squared is a quadratic because the only exponent I see there is 2, which means the highest exponent is 2. And we will see that it will end up looking like a U shape. We call that U shape a parabola. We don't just go ahead and draw a U, that's going to do nothing for us. We actually need to make points so then we get points. So let's make an X and Y table. I like to write my table down. That way if I ever made a mistake on my graphing, at least I have my table to back up what I did. So let's go to the table. I'm going to try to go up to -10, but those numbers get too big. So I'll start at -3, 9, -2, 4, -1, 1, 0, 0, 1, 1, 2, 4, and 3, 9. That's all I could graph because all the numbers are either bigger or smaller than -10 and 10. Alright, so -3, 9 means you go to the left 3 and you go up to 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Then -2, 4, 1, 2, 3, 4. -1, 1, 0, 0, 1, 1, 2, 4, and 3, 9. Alright, so you will see it looks like a U shape. Just because of how you put your dots, it might look like a V, but it is a U. And we put our arrows going up. So if we just look at some things that we could tell about this parabola. I hope that when you guys were graphing it, you were able to tell that numbers started repeating. The 9's repeated, the 4's repeated, the 1's repeated. You should see that this 0, 0 is the middle of our parabola. You could also think of it as like this y-axis. If you think about it, that splits the parabola in half. These are all key features that we are going to talk about, and we're going to learn what the names of these key features are. So today in this lesson, we're going to learn how to graph and interpret the key parts of a quadratic function. Remember, quadratic means the highest exponent is a 2. So let's go over what standard form of a quadratic is. Standard form of a quadratic is when you write it as y equals ax squared. A is a number in front of the x squared, plus bx plus c. B and c could be equal to 0 like it was in the do now, but a can never be equal to 0 because you need to have an x squared in the problem. So a has to either be 1 or higher. And the focus of this unit is going to be, we're not only going to learn how to graph these quadratic functions, we're also going to learn how to solve them. And we want to always try to write them in standard form. Alright, so let's look at the first two things we could be asked. One of the most important things we could be asked is, what is the x-intercept? But most of the time they don't ask it to us as an x-intercept. They like to use the word roots, zeros, or solutions. Those are 4 different names that mean the same thing. X-intercept, roots, zeros, and solutions all are where the graph crosses the x-axis. And here my graph crosses the x-axis at x equals -1 and x equals 3. If you look back at those points, -1 and 3, those are the points where y equals 0. So we have an x-intercept wherever y equals 0. And now for our y-intercept, the y-intercept only has one name. The only name for the y-intercept is y-intercept. That is where the graph crosses the y-axis, which here that would be y is equal to -3. Alright, other things we could be asked about these are, what is a minimum and what is a maximum? A maximum happens when you have an upside down parabola, a parabola that looks like an N. The parabola is pointing downwards, which means you never know how low it's going to go. It's going to go all the way to -infinity. But you do know the highest it's ever going to get. It's never going to get higher than that. And then the minimum is you're jumping up, it's going upwards, and you do know what your minimum point is. You know how low you could go, but you never know how high you're going to go. Other things, this is a review of the past. We have done this with other type of functions that we have graphed. We might want to tell what the domain and the range is. The domain talks about x values, which in order to find your answer, you're going to ask yourself, how much to the left and how much to the right does my graph go? The range talks about y values. Here you would be looking about how up and down does the graph go. And then increasing and decreasing, that one should be a little bit more obvious. Increasing tells you which y values are going up, and decreasing tells you what is the interval where the y values are going down. And now, axis of symmetry. If you think of axis of symmetry, this is going to be the line. It's always equal to x, because remember, horizontal lines are x equals. This is going to be the x equal line that would directly split the parabola in half. It would make each sides equal. If you see, each point on both sides are going to be equal. And then the vertex is the point that goes through the axis of symmetry, and that is where the parabola starts to turn. If it was decreasing, then it goes to increase. If it was increasing, then it goes to decreasing. Alright, and what is a way that we could algebraically find the axis of symmetry? We can use this formula, x equals negative b over 2a. A is a number in front of x squared, so here in this example, a is 1. B is a number in front of x, so here it's 12. And c is the number, the constant, that doesn't have an x, which is 32. And we would plug those into the formula, and we would get that here the axis of symmetry is x equals negative 6. Alrighty. How are we going to graph them? We're going to find our axis of symmetry. That will let us know what our middle point is. We pull up the table. We get some points above the axis of symmetry, some below, and we graph it. Alright, let's look at this one. We are graphing y equals negative x squared. Okay. If I hear negative, I'm going to assume something about going down, which I do see here. It's going to be like an N shape almost. And let's look at our table. Again, I wouldn't go all the way to negative 10 because those numbers are going to be too big. But I could start at negative 3, negative 3, negative 9, negative 2, negative 4, negative 1, negative 1, 0, 0, 1, negative 1, 2, negative 4, and 3, negative 9. Axis of symmetry is the point, the turning point, where everything else starts to be the same. And if you see, here we have this negative 1 is the same as negative 1. Then we have negative 4 is the same as negative 4. And then we have negative 9 is the same as negative 9. So our axis of symmetry here would be x is equal to 0. And now let's graph this. Negative 3, negative 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Then negative 2, negative 4. 1, 2, 3, 4. 1, 0, 1, 4, and 9. Perfect. And now let's connect these points. And we're going to put the arrow at the bottom because it's going down. And it looks something like that. Alright, so sometimes in the regions, the first step of a question will be for you to graph it, but then they're also going to ask you questions on it. These are examples of questions they could ask you. First, they could ask you, what is the x-intercept? The x-intercept is the point where the graph crosses the x-axis. Sometimes there could be two of them, one of them, or none of them. Here it only crosses once, and it crosses at x equals 0. And our y-intercept. The y-intercept is where does the graph cross the y-axis? It crosses at y equals 0. Vertex. Vertex is the middle point, the point that is directly in the center, and that here would be that middle point 0, 0. And now you got to think about, is there a minimum or a maximum in this parabola? If this parabola is pointing downwards, that means there can never be a minimum because I never know how low it's going to go. It's going all the way until negative infinity. But I do know what the maximum point is. My maximum point is 0, 0. That's the highest that the graph is ever going to go. Alright, let's try another one. We're literally doing the same thing and we're using our calculator to our advantage. Let's type this in. X squared minus, just make sure you're typing in exactly what you see there, x squared minus 2x minus 8. Enter. And then click table. And now we want to, let's see what we can graph. I can't graph negative 4, 16. That's too big, but I could start graphing here. Negative 3, 7. Negative 2, 0. Negative 1, negative 5. 0, negative 8. 1, negative 9. 2, negative 8. 3, negative 5. 4, 0. And I could do 5, 7. You don't have to write every single point down. Now, if you don't want to do the math, you could also think about where's the axis of symmetry by what is the point where stuff starts to repeat. And it is right there. And axis of symmetry is always going to be x equals and 1. Let's say we want to algebraically find the axis of symmetry. We use the formula x is equal to negative b over 2a. here in our formula, our b is a number next to x, which is -2. And our a is a number in front of x squared, which is 1. And if you guys type this in the calculator, you would get x equals 1. Let's graph this. 1, 2, 3, up 7. 1, 2, 3, 4, 5, 6, 7. Then -2, 0. To the left 2, stay. Then -1 down 5. 1, 2, 3, 4, 5. Then 0 down to 8. 1 down to 9. 8 here, here, and up to there. Alright, let's connect our points. Let's put some arrows, and it will look something like that. Very nice. And we're going to answer our questions. Again, does this one have a minimum or a maximum? It's not going to have a maximum because it's going really, really high. I don't know how high it's going. But it does have a minimum. And what is this point? This point is +1 down to -9. Yep. Now, domain. Domain talks about how much to the left and right does this graph go. If I follow the line and I go all the way to the left, I'm never ever going to stop. If I'm never stopping, that means I'm going to -infinity. And the range, I'm going to go all the way to the left. If I'm never ever stopping, that means I'm going to +infinity. Now the range is how low does my graph go. The lowest point on my graph right here is I went down -9. So my range would be, the point is included, -9. And if I go up, 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 I never know how up I'm going, so I'm putting infinity. Very nice. And let's try our last problem, this you do problem. Let's try it. Y is equal to -x squared. I already know it's going to go down because I see the negative. 4x minus 5. Enter. Let's go to our table. Let's try to find the axis of symmetry ourselves. So x equals -b over 2a. So we have negative, the number in front of x squared is -1. And I meant the number in front of x is 4, because that's our b value. And then 2, and our x value, our a value is the number in front of x squared, which is -1. This will leave us with -4 over -2, which means 2. So our axis of symmetry is x equals 2. That means that at x equals 2, that could be like your middle point. Alright, so we'll start with -1, -10, 0, -5, 1, -2, 2, -1, 3, -2, 4, -5, and 5, -10. Let's graph it. And then it's nice once you see that everything starts repeating. Let's connect the points, and let's put our arrows. And then we are going to need to tell a little story about this stuff, so let's see. First, they want to know what the vertex is. The vertex is the middle point. I went 2 to the right and down 1, which would make my vertex 2, -1. That's also our highest point. Our graph is never going to get higher than that. I know that might be a little confusing to you because you're like, it's not high if I'm in the negatives, but it's still the highest negative number you're ever going to get. And now we want to think about, where is this graph increasing and where is it decreasing? This section of the graph, if you see I'm going up, that would be my increasing section. And this section would be my decreasing section. And they stop increasing and decreasing at x equals 2. That's when it's just at, when it stops increasing and then becomes decreasing. So is it increasing when x is less than 2 or greater than 2? Well, if it's increasing for everything to the left of the line, that would be when x is less than 2, which means that it's decreasing when x is greater than 2. And let's just do a little review from the past. We need to make sure we know what the names of these graphs are and what they look like. For the positive of y equals x, that would be a linear function. That is when the same number is being added. This could be changed to x plus 4, 2x plus 3. It's just when you have a plus in there. Then this one, those lines mean absolute value, which absolute value v looks like a v. Then whenever you have an exponent that's a variable, that's exponential. And an exponential function looks like a little curve. And the last one is this new one that we just learned today. It's a quadratic. It looks like a U. You need to know the names of these and know what the difference between them is. Alright, that sums up our lesson on how to graph quadratic functions and how to interpret them.